So today we're talking about multiprocessing for reinforcement learning algorithm because in the previous video I showed you how I train my algorithm, but it takes too many times, and reinforcement learning where it's sensitive to train using multiprocessing or your GPU video card. The most important for us to use multiprocessing for training algorithm. It means when we split episodes or some scenarios on batch size and trying to fit this data to our algorithm, and it would be processing more quickly. And I would like to show you how I implemented this one. So I rebuilt too many code again because I would like to adapt my project for multiprocessing. For me, it is a very important part right now because I would like to scale this one. I would like to run this one on powerful computer and train my algorithm. So how it's working? For example, I have file, this train.py, and I just need to run some command line. For example, I would like to indicate to get data, Bitcoin USDT. I would like to use window back 30, episode 31, non-processing 16. And this feature I'm working to store data to database in real time. It means I would like to display all this data for you for interface on website. Maybe we're creating something to interact with this feature. Okay, so we're using multiprocessing library and create this feature. And this stuff very interesting function star map, and we create a pool with different combination of our data. It means we indicate episode count 16, and we split this feature to our episode count 32 and split this one to 16 process. But of course, to train our algorithm, I should run on 1000 episode and split many process like 32, for example, and trying to use this one. And using pool star map, we need to input our method when we are going to train our algorithm, and indicate our agent and stock environment, and then we loop all this feature through our episode count. And let's look on our train episode. What is agent? And let's look on this function. You see, I need to create agent outside of this function, and it would be our agent. And we initialize our agent with window back, and inside this agent we have all memory, and it would be memory, and it means the memory would be common between all this process. And then we need to input environment, but environment would be separate for each process. Let's look in. I'll show you what it means. Okay, and you see, this is my right now I'm testing this feature using some simple environment to create a quick process for developing. So this would be environment, and inside in this environment we input agent because we train our agent, and inside this agent we have a neural network, and we need to predict action depends of situation of the market. And if you split this data to 32 process, it means it will be a different 32 a different environment. Yep. And inside in this environment also we can input stock name, for us it will be cryptocurrency, and window size. But for me, what would be very interesting, split data also to different cryptocurrency, like this one I show you. For example, using this function, we created too many combination using episode count and what is this cryptocurrency names here. I'm using stock name because I need to create this one also for stock market. Okay. And for example, right now I would like to train, create multiply environment with multiply cryptocurrency and multiply epochs, yeah, to train agent. And let's look in on this function, train episode. Yeah, I just input this function, train function. Let's look in what is it. So yeah, I created inside in this function data collector. It is some simple class to collect all this data to dictionary, and then I would like to save this data to CSV file to analyze, yeah, in the future. Okay, so we create data collector, and then this is the same. We have it done by default will be false. Next we reset our environment. Next we go through all our data set. Is indexes, and it's a number of rows inside our data frame. And then we create what is the action from agent. Next we input this action to our environment and looking for what happens there, what would be reward, next date, or done. It means if our data frame is end, we need to break our processing. You see, like this one. This scenario, it means the data set is end, and we need to store information. Yeah, and inside in this data collector, we input what is the episode, what is the index, what is the action, and total profit. It's like accumulate total profit from there. Also reward, because reward and real profit would be different, because for agent we need to input positive reward. I mean positive or null, yeah, 0 or positive reward instead of minus. It is policy to reward our agent. It could be different policy, but right now I'm using this approach. And also I'm using epsilon. Yeah. And there exists some problem. I'll explain it a little bit later. Okay, so I train this one. So we create multiply of environment. Yep. And in this train our episode, let's look in train. Yep. And we go through this loop, and then we store our models. Yeah. It means I just parse an argument from this file. Next we do utilization of agent, like a global variable, and then we input this agent inside in this function, and then we create multiple of environment, and then we need to save our model, and model would be saved in folder models, like a final model, because I would like to test this one or to make prediction in real time. So let's look in how it's working. So let's look in for process, and episode is 8 is for demonstration how it's working. show you. So we get data from this folder. See, I have data for train and for test data. Yeah, of course, there I create some data downloader. Explain you. Okay, so let's look in what happens inside in this terminal, and you see we have episode number 3, episode number 1, episode number 2, a different episode, and inside in this separate of this environment we do on logic to trade. It's and then we need to wait and analyze how this algorithm is training. Let's, for example, create more process. Okay, more process. For example, let's create 16 and episode is like this one. Okay, it's for demonstration. Okay, maybe my laptop will freeze. Okay, let's wait in. Yep. Okay, it's, I need more buffer for laptop. It's my working laptop is another. Okay, so and you see we have different episodes, and we're trying to trade inside in this environment. Okay, I stop this one. Where is? Okay, like this one. Episode 30 is and we sell, buy, sell, buy, sell. Okay, so I solve the problem to scale this reinforcement learning for different episode and different environment. And right now I need to implement a feature to train on multiply cryptocurrency. For example, Bitcoin, Ethereum, XRP, Cardano, Solana, or something like that. To go through all this experience, and we can create maybe something powerful. Okay, what is the problem with epsilon? I show you. Let's look in on the results. For example, I save all this data to this folder, and I just create some simple picture notebook to analyze all this data. It's some feature for Redis, because I would like to store this data on the Redis to create dashboard. Okay, right now what I'm going to do, I'm going to read all these files from folders, yeah. And then I need to take from this data only columns with rewards. It's you see, it's too many some datas, and I do this number 2. It means our cumulative return will be there, but I need to processing this data to flow data instead of string, because I store like a string format. I show you where it is. Okay, like this one, you see, like a string. Okay, and then I take this all columns, and you see I have 32 different columns, because I have 32 episodes with number of rows. And then I can analyze all this one, and then I can plot all this data here. Of course, results is not good, but we need to work to improve this one. So it means some episodes it would be successful, some not successful. because I train only on 32 episode on the data for the last 10 days maybe. It is a very short piece of training. Yeah, and this one displays this accumulated reward. Accumulated reward in general, we see we have more positive rewards, cumulative rewards than negative, and it means we can train our algorithm. And yeah, and of course I create some very simple statistical tests to prove what is the episode would be with statistical significance. Yeah, I need to estimate we really find some dependency on the market or not, and how to do it. So we need to create this piece of code. We need to accumulate some random rewards, and then we create like some cumulative returns, and then we go through our data set with trained results, I mean from this CSV file, and then we just implement this statistical function, and we estimate if our alpha would be more than 5%, and it means we haven't any real statistical dependency between random data and what we got from our reinforced algorithm. Yeah, and when I run it, I have episode number 11. There we haven't any dependency, and this one, it would be this one, you see. Okay, but this stuff it's just to quickly estimate and to use this test, it could be danger. But for quick estimate, it would be okay to understand how distribution of our data differs from some random. Okay, so let's look in another to estimate this data. I just need to indicate test. Yeah, for example, this is my test file, and what I need to do, I need to go from our agent and indicate epsilon. Okay, let's come back to feature what I forget to explain. So when I create environment, we have the same epsilon. It means epsilon, this is value, some criteria to explore our data. It means if epsilon would be 1, it means in 100% of cases we create some random action to explore our environment. But during this train, our epsilon is decreased all times, and we indicate like only I show you only like 1% of cases would be like explore, yeah, some explore environment to find some more dependency. Okay, and for us it is a problem because I create a different multiplier of this environment, and inside this environment for each episode we indicate epsilon 1. Yeah, and again we do some too many explorer of data, but I need to fix this value, fix this feature using to create some common list inside in this stock environment. It means all this processing should be communicate should be communicate with this common value. How it's working? I show you, for example, that we have some feature like manager, and inside this manager we need to run with manager as manager, and inside this manager we should input to our stock environment, for example like this one, and inside this in this environment, where is our epsilon, we need to create like a common value of all this process. Where is this epsilon? I need to find the solution. Okay, current step, you need batch size. 1 second. Epsilon. We need to create this epsilon inside in this our agent. Where is our agent? Would be here. And inside is our agent. We should input manager here, and inside of this manager you should use this feature, something like that, but it's like a schema, and I need to find and test this one, but I'm not sure. It's like some ideas how to solve this problem, to create a common epsilon between all this process, because I don't like that in each different process we have the same epsilon. We have different epsilon. It means if I trained my model effectively on episode number 10, and you should remember all those results instead of initialization epsilon number 1 on next episode. It's not make sense for us. And then I fix this one. Okay. Next, how to train and test. For test this feature, I indicate what is the cryptocurrency and what is the model I would like to test. I store the model here. Models after train. You see, after train I save this model. So we do, you see, some testing without multiprocessing. Okay, and then what I need to do, I need to also implement database. I started to working with this one, but I need to more times. It means, like you see, I would like to create or Redis or Postgres. I think it would be Redis, and then I have database, and like this one, you see, Redis data store, and then I just store all this information about training this algorithm, because for example, when we run this algorithm on multiply of data, it takes several days on the server, and we need to analyze we need to analyze all this data when this algorithm is trained, because it not makes sense if something would be wrong and we wait on 7 days, and after 7 days we understand, oh, it's not successful, it's something we can we missed something and we need debugs. some feature there. So as monitoring process is very important. Yeah, also implement for database, like to store all this one. And yeah, and I need to improve my downloader in some class for downloader data and how it's working. For example, this get data, and I need to indicate what is the data I would like to download. For example, data for the last 10 days, what is the tickers, what is the time series. Yeah. So guys, there exists too many work. Yeah. And I just show you my progress. Maybe it would be interesting for you how to implement for this one for multiprocessing, and you can control step by step all action from your models to understand how it's working, because when you're using something black box from some library, you can't understand what happens inside there, and you need to feel all process of development. And when you using this approach, you have all time some new ideas how to improve this one. Okay guys, I think and I hope it will be useful for you to implement this multiprocessing for your reinforcement learning project. See you, bye.